Estimating population proportions. And what we're going to use to do this estimating is confidence intervals. And so hopefully you've heard of that. Maybe you have. Maybe you've seen something like, I don't know, maybe an election poll and it was something like 40% plus or minus margin of error. That's what's going on with this. This involves proportions. Proportions nothing more than total the desired number divided by the total number. It's the fractional part of a total. So p hat represents a sample p hat, and it's just x over n, and that is the best point estimate for a population proportion. Population proportions a p, or it could be a p sub 0, just depending on the book. An interval estimate is just an interval that estimates the population parameter. Level of confidence denoted by C, that is a big deal. If you hear someone say we're 95% confident, which is a common word number you'll see or hear, 95%, that's the level of confidence. You've probably seen the range rule of thumb. If you remember the range rule of thumb, things are significant if it's plus or minus mu plus or minus 2 standard deviations. That's because most data values, or most whatever, that follow a normal curve fall within plus or minus 2 standard deviations, which is recognized as 95% by the empirical rule. So it follows the same kind of reasoning. And we're going to use a confidence interval as just a special interval estimate using the level of confidence. And then the margin of error, I've already mentioned that in this video. We'll use E, and that's just a distance greater than the population mean and then less than the population mean. And kind of a way to think of that is, let's see if I can find that somewhere, if that's somewhere around here. And it may not be here, it's probably down here. There we go. This. Or this. So our confidence interval, all we'll do is we'll just take our sample proportion and subtract E and then add E, and that gives us an estimate of the population proportion and the interval that it's in between. That's actually way off, by the way. It's because there's all kinds of rounding off errors. So if you see 5% plus or minus 3.5% is a common one you'll see on the news or whatever, and maybe further apart, further away than that, because there's all kinds of rounding issues. Now something major is this z alpha over 2. Where the alpha comes from, it comes from 1 minus a confidence level. It is a big deal. Later on I won't tell you what it really is, but later on you'll find out if you continue with the class and with the videos. But it is a really big deal. We're going to start doing hypothesis testing. It's going to be the alpha level that we're going to determine whether or not we have sufficient evidence or significant evidence, however you want to say it. Since we're dealing with confidence intervals, we're looking at in between. So we're looking at what's going on in there, just like the range rule of thumb. So we're really not looking at what's in there, we're looking more at what's going on over there and what's going on over there. But the main thing is that we're going to divide up based on what our C is. So we're going to be looking at the tails. So you can think of alpha or C, if area in the middle of the curve equals C. So if that's like C, then that's going to be alpha over 2, and that's going to be alpha over 2 also. Because what is alpha? Alpha is 1 minus C. And that's kind of what we're looking at. It's kind of a diagram to look at. I'm just trying to think of a way to make, maybe this may make more sense, but that's what it says. 1 is the whole area, C is what's in there, and so what's left over is in these two tails. The two tails combined equals alpha, equals the combined area. So when you divide them up and it's all symmetrical, then you get A over 2 is area in each tail. And so what we're going to be looking for is for this critical value and then this critical value, which is actually the same thing as this critical value, except it's the negative of it. So that's referred to as a critical value. Critical value. Critical value. Some books use like Z asterisk, and that's okay. So to give you an idea of what's going on, here's a couple of examples to start with before we start finding confidence intervals. We're going to find the Z alpha over 2 that corresponds to a 94% confidence level. Now the confidence level, the 94% represents this area. So this is 94%, which is the same thing as 0.94. So we're looking for the Z alpha over 2. We're always looking for the positive value. But we need to know what that area is. But to find that area, we have to find that area. So to find that area, which is actually alpha, but to find the remaining area, you take 1 minus 0.94, which is 0.06. And so you take that 0.06 and you divide that by 2, you get 0.03. So what that means is that area is 0.03 and that is 0.03. And if you add those up, that's actually 0.94. 0.94 plus 0.03 plus 0.03 equals 1. So the question is, what is this Z alpha over 2? That's where you got to start thinking about, if you use a table, you got to think about a table. Tables are always areas to the left. So if you think about that, so we come over here and draw a picture. Same picture, just not as much information. So if I draw that and that, it's just these two tails of the same area. And now from there to there is 0.94, and that's going to be 0.03. All the way across is 0.97. Makes sense? And so if you're looking for a table value, you have to look for the table value of that's closest to 0.97 and then find that z-score. I'm not going to do that. There's a faster way. Calculator. I'm also going to use Statcrunch. Calculator is always area to the left. Keep that in mind. So what I'm going to do is I'm going to go to second vars. This one has an inverse norm, and they all do. So does the TI-83. That's number 3. This is always area to the left, so I'm going to have to type in the 0.97. If I do 0.94, I'm not going to be including this. So I need to include all the area, all the way down. 0.94, 0.03 is 0.97. Since this is Z, keep the mu and the sigma 0 and 1. And see what I did? I almost left this 0.94 because I was thinking about 0.94. It should be 0.97. And we get 1.88. Now, if you do this, and that's okay, if you do recognize once you have 0.94 is in the middle, because when you do confidence levels, it's always in the middle. Because like I said, if you remember the range rule of thumb, all the information's on the left side and the right side, right side. So if you just find like 0.03, that is totally fine. I'm going to just do second vars 3. If you do 0.03, remember what I said. We use the positive. So the negative is fine. Just remember, use the positive value, 1.88. And that's the answer. Now if you use Statcrunch, that's what we can find. Statcrunch, calculator, normal. Since we're starting in 0 or in Z form, we're looking for the Z. Keep the mean standard deviation the same. We're looking for, and the picture is a big deal, area to the left, which is 0.97. So, and by the way, area, probability, proportion, percent, they're all the same question. So even though I may use the word area, it's the same thing as probability. Same thing as proportion. Same thing as percent. All the same questions. So looking at 0.97, so we want the probability is 0.97. Now if I click compute, the picture should be similar, and it is. See that? And I get my 1.88. So it matches up with what I drew. See that? That's why I like Statcrunch. You can see what you're supposed to be doing. And once again, if you use 0.03, you'll get the negative, and that's fine. It's just that part over there. Just remember, use the positive value. So keeping that in mind, let's do this next one. First thing you want to do, this one's 9%. If you know what you're doing, you should know by now it's 0.95 is what you're going to be looking for. The more probability where the area is 0.95 or 0.05. Do you see that? And if you do, what I'm about to do, it will make a ton of sense. 90%. Same thing as 0.90. And that's in there. It's 0.90. So when I take that and divide it by 2, oh my bad, don't want to divide by 2 yet. I'm getting ahead of myself. When I subtract it from 1, we get 0.10. And when I divide that by 2, we get 0.05. And that's that area, and that's that area. And so the area we're looking for, it goes from there all the way to the left, which is 0.95. Did you catch that? Let me do it again. This is by far the most important thing. If you understand this, life is going to be really good for you. As far as this class goes, that is. So 90%, 0.90 is in there. That means that's 0.05 and that's 0.05. We want this value, which means we need the area all the way to the left, which consists of 0.90 plus 0.05, which is 0.95. So we take out our graphing calculator, go to second vars, hit 3. We want area 0.95. If you use 0.05, that's fine because you'll get the negative. Just remember to use a positive. And we get 1.645, which is very, very common, by the way. It's a very, very common one. 1.645. If we use Statcrunch, keep the mean and standard deviation 0 and 1. We want the area, which same thing as probability, is 0.95. It's like a backwards question. That's why it says inverse norm in the calculator. And you'll see that when you round. That's probably the hardest part, by the way. Now, you can read this for yourself. I'm not going to read it to you, but the margin of error, this is actually the formula for it. I may attempt to use the margin of error formula to do this, and there's another way to do this also. And this is a confidence interval. I may do some of it by hand just a little bit, but I don't really have to. And I'm going to come back and look at this minimum sample size. So, here's the margin of error formula. It's a big, big deal. The reason I'm not looking at it too much because I'm going to use my calculator. I'm going to use Statcrunch. Save us a lot of time because you can tell it's not the easiest formula in the world to use. All this information is the same thing as what I've just been doing. The Z alpha over 2. That's why it's a big deal. N is still sample size. P hat sample proportion. N is sample size. But you're about to learn some things about technology. This I don't worry too much about, but this part right here, this I'm not worried about if we're doing it all by hand. But this is what I'm going to look at. I can actually find the confidence interval and then subtract the upper limit minus lower limit and divide by 2 to find the margin of error without having to use the formula. I'll come back to the sample size, minimum sample size later. So let's do a couple of questions involving what we just looked at. The main thing is for this first one, it's only asking for a point estimate of P. And that's just P hat. That's all that means, find P hat. And that's found by X over N. So X is 183 because you have to have something to start with. So just take out our calculator and just type that in. Not a big deal at all. Make sure it's right number, 700. 0.261. And it looks like the answer is C. That's all I was asking. So if you ever see that point estimate, that's what that means. Find the sample proportion, X divided by N. Now this one's a little bit different. This one is 460 junior college students. That's our N. I better write it over here because my calculator tends to pop up over there. Try it over here on the right side. And our X is 100. 99% confidence level at the confidence interval. We want to find the confidence interval, but for the proportion. Okay, if I were to do this by hand, I would need p hat. Let me do it by hand once. So I really don't want to do this, but I'm going to. And I'll need my margin of error, which is z alpha over 2 times sigma over the square root of n. And so 100 divided by 460. I really don't even want to do this because it might have to round off. Yeah. I'll rather leave it as a fraction, but it's just going to round off 0.2174. And then this, the ZF over 2, that's where I got to think about 99%. And you come up here and just think about it. There and there, that's 99% or 0.99. 1 minus 0.99 is 0.01. I need to divide that by 2. 0.005. If you don't believe me, do it with the calculator. 1 minus 0.99 divided by 2. And that gives us the tail area, 0.005. And that is a big deal. I'm going to put it just over here. Because what we're looking at is 0.99 plus 0.005, which is 0.995. And I need that. If we're going to do inverse norm, 0.995, 2.576, and that's my z asterisk. Or critical z, using my inverse norm. And then times sigma, or is it sigma, or is it something else? Nope, that's a different formula because it's this uglier formula. See, sigma over n is what we've been using if you watched my previous video, where we were just using central limit theorem, or maybe a previous lesson. So this one's even worse. It's why it pays to always pay attention. This is getting even uglier and uglier and uglier. That's p hat 1 minus p hat over n. Hope y'all can see that. You know what I did? I should close that one off. You're going to appreciate what I'm about to do later. I'm running out of room, and that's messy. I'm kind of glad it's getting messy. You'll appreciate something I'm going to show you here in just a second. A whole lot more. So it's 2.576 times the square root of 0.2174, 1 minus 0.2174 divided by n, which is 460. This will be the last time I show something like this by hand. Just want y'all to know that. .576 times second square root. Put that in parentheses. 0.2174 close. 1 minus 0.2174 close. Divided by 460 close. Enter. 0.0495. that's the margin of error. So to find the confidence interval, you'll take the p hat and do 0.2174 minus 0.0495, comma 0.2174 plus 0.0495, which gives us this 0.2174 minus 0.0495, and if you notice, I've been rounding off all over the place. And do the same thing, but this time do plus 0.2669. Was that fun or what? Now, if you've been watching other videos, you've been wondering how come you haven't been showing all the work, because you can fool me till I can. Just let me know. But that's why that's quite a bit of work. I didn't have to do all that. Watch this. If I go to second vars, and if I maybe it's not second vars. Maybe if I go to stat, let me go over to test. Okay, do you see anything in there? Not yet. Oh, do y'all see that? Let me do it again. Go to stat, go over to test, and scroll down. One prop z interval. That's one proportion z interval. That's what I'm going to use. Watch this. X is 100. N is 460. Confidence interval is 0.99. Confidence level, I mean. Enter. Oh, I missed that. Let's do it again. It's already, all the information's already in there. Just got to find it. I clicked too many times. Enter. Looky there. You see that? 0.6785, 0.1679, 0.2669. Now, do you understand why I've been showing you this? I'm trying to make your lives a lot easier. Please take advantage of your calculator, or if you don't have a calculator, which is fine, Statcrunch works just as well. See what we can find. Stat, and then let's see, which one is it? And if you can't find it, you just come down here and you start looking for things and see if you can find maybe one sample z, because this is a z. Or I see the word proportion now. That's a better thing to use. One sample with summary. So the number of successes is the x. I'm not sure what that is. Is the x, which is 100. N is 460, because that's the number of observations. Confidence interval, which is 0.99, confidence level, confidence interval. And let's just click compute. Let me minimize it. Do you see anything? 0.1679 for round off, 0.2669. Do you see that? Do you see those? Do you see those? Do you see what I'm saying? There could be easier ways. Just want y'all to see that. So, when I do this one, and by the way, once I have these intervals, 0.2669 minus 0.1679, divide that by 2. See that margin of error? I could have done it backwards. So let me show you what I'm talking about. Let me show you what you want to do. First thing to recognize, we're looking at a proportion. This is going to be way faster. So we have n is equal to 820. This time we're given a probability of 0.61 or 61%. We need an x. The way you find the x is you take 0.61 of 820. Got that? And that's just actually basic math with percents. 61% of 820 is 500.2. Yeah, I know you can't have a 500.2, but I just use it anyway. We will have a confidence level of 90%, which is the same thing as 0.90. So let's take out our calculator and just see what happens. Want to? Let's stat test. You can go down or go up, either way. One prop Z interval, or just hit alpha A if you want to do it that way. The reason why I had to find my X is because I knew I had to type it in there. N is 820. Sea level 0.90. Enter. Enter. Oh, domain. That's probably because I used something I shouldn't have. I probably used the 500.2 and you can't, so we just use 500 then. See that? So this is actually our confidence interval. Point 58174. Comma 0.63778. And what that's actually saying is we are 90% confident that our true population mean is between 0.58174 and 0.63778. That's what we're saying. Instead of this 0.61. Got that? So we're 90% confidence stays between these two values and not that 61%. And that makes sense because 61% is actually in between there. You can also use Statcrunch. Let me minimize this. See if I can type in 500.2 on that one. So let's go to stat proportion one sample with summary, number of successes. Adapt. We'll just see. Number of observations. Confidence interval. The level is 0.90. Let's click compute. Well, it did let me do it. Interesting, isn't it? So Statcrunch may be better. It's probably more accurate. See the 0.58198? That's pretty close. 0.58174. Probably rounded off range, so it'll be allowed, be permitted. See the 0.638? If I do 3 decimal places, it will be okay. Yeah, if I do 3 decimal places, it won't be an issue. I'm just trying to move this over so you can see the upper bound, the right bound. So I'm going to say that it's probably going to be rounded to 3 places. That way, no matter which way you go, whichever technology you use, you won't have to worry about any issues like that. Now, but still, yeah, see that. I mean, that's probably the easiest way of doing those. I mean, actually, really easy ways. So either calculator or Statcrunch. Either way is fine. Now, these examples, calculator is not going to help you do much other than finding the critical Z. So there's a formula we're going to use. The formula actually comes from the margin of error. And by the way, while I mentioned margin of error, if we want to find the margin of error, if you wanted to, we could just do this. 0.58174. My bad. I need to do bigger minus smaller. 0.63778 minus 0.58174. Divide that by 2. Margin of error is 0.02802. It's a backwards way. If it doesn't work because of some kind of rounding error somewhere in the range that's accepted, isn't big enough. So let's look at this. The formula we're going to use actually comes from the margin of error formula, but that formula, you won't have to worry about memorizing it because it's going to be given to you somewhere, is right here, and that does have all the components of the margin of error formula. I think your book may use a slightly different variation of it, maybe not. If it does, no big deal. Deal with the exponent. But it's n equals p hat times 1 minus p hat, or p hat times q. Some books have a q. z alpha over 2 over e, all that squared. This is what we're going to use if things are given. So n equals z alpha over 2. No, that's not it. I'm trying to do my memorization. P hat 1 minus p hat times z alpha over 2 divided by e squared. Let's make sure that I did that correctly. P hat 1 minus p hat z alpha over 2 over e. Let's see what we can find out here. How large the sample? That's what we're using. We're doing the n. N means how many. To be 98% confidence, we're going to use that to find z alpha over 2. Let's go ahead and do that. That's 0.98. If you do 1 minus 0.98, you get 0.02. Divide that by 2, you get 0.01. So that's 0.01. Grand total 0.99. So I'll go to my calculator. Let's go to Statcrunch this time. So I don't think I used Statcrunch last time when I did something like this. So they're looking at 4.99. So let's go to Stat Calc Normal 0.99 and then compute. We get 2.326. 2.326. .326 because we use 0.99. Get that? And if you want to use a calculator, we'll go ahead and do that. Second vars inverse norm 0.99. See that? Same thing. So we already have the numerator. P hat. You gotta be really careful how you read this. When that differs from true proportion by more than 3%, that actually is our margin of error. So as a decimal, that's what we'll use. The previous study indicates the proportion of left-hand scientists is 9%. So that's gonna be our p hat. So 0.09. 1 minus 0.09. And it could be a p there. Just depends. But it should be a p hat. And so, this is all calculator. So let's take a look at this again. Let's review it. I use the 98%, recognizing that's the middle 98%, and then if I divide it by 2 to get the two tails, that's 2% total, 1% in each tail, it gives me 0.99. Look at 0.99 either in calculator, Statcrunch, or table, and I find the critical z of 2.326. We're told that we don't want to differ. Anytime you see words like that, that refers to a margin of error by more than 3%. As a decimal, it's 0.03, so that's why e is now 0.03. And we're told that in a previous study that the proportion, the p hat, is 9%, which is 0.09. So I just type that in, or substitute it in for p hat. Then we'll take out my calculator and attempt to type it in correctly. I'll move it over here so we can see it. So 0.09, I'm just going to type it in like it is. Parentheses, 2.326 divided by 0.03. And don't forget to square it. And then I think you always round up. So we get 492.3 and you round up to make sure you have enough in the sample. I think you always round up. If it's not, your book will tell you, or your homework will tell you. But this problem says you round up, to round up. Now if you look at this question, 95% confident is an error by no more than 3 percentage points. That's plus or minus 3. Those are margin of error. And so this is the percentage. So I'm looking at this. Let's read this. Make sure we know what we're looking at. So when you look at this, when there's nothing, no information given, we're looking at 0.25. And I'll tell you what's going on. It's the same formula that we used, except we're assuming that p hat is 0.5, 50-50 shot. That's kind of what's going on. So margin of error is 3%, so we use 0.03. Since we're doing proportions, you always want to use the decimal, in case you're wondering. So a margin of error, or my bad, the n, just to show you, that really is the same formula. Instead of using p hat, we're going to use 0.5 times 0.5. And that's how they're getting that 0.25. Let me show that formula again. I'll explain that here in 1 second. See the 0.25? The reason why when that's being done, unlike this first one, you're told that from our previous study, proportion is 9%. On this one, there's no prior information about population proportion. So keep that in mind. It actually looks like that the formula could be a P. Some books have P hat, some use P, so be aware of that. Doesn't matter, just be aware. So the reason why it's 0.25 is because 0.5 times 0.5 is 0.25. That's where that comes from. In case you're wondering, it just wasn't thrown out there. But we need to find a z alpha over 2, and the e is 0.03. So the hardest part, once again, is z alpha over 2. So if we have 95%, or 0.95, and if you subtract that from 1, you get 0.05, and if you divide that by 2, you get 0.025. And so what you're going to use then is 0.975, because, in case you are wondering, 0.95, well, 1 minus 0.95 divided by 2 plus 0.95 gives us the 0.975. That's the process. Keep my calculator because it's already handy. So I got a second vars 3.975. Just keep hitting enter until we get an answer. 1.96 is what's actually used by most tables, most books. If you want to use a calculator, 0.97, or Statcrunch, I mean, 1.96 also. Okay, now let's take out our calculator and type this in and see what results. So 0.25 parentheses 1.96 divided by 0.03 close squared, enter, and we do get 1067.11, which rounds up to 1068, which is the sample size needed, and that's it.